Hi everyone, and welcome back to Maths and Physics, Mr. Simons. Right, today's lesson on vertical projectile motion. We're looking at the fifth variation of 7 exam questions previously tested. It's where we're testing the bouncy ball question, but via a graph that we given to you. Comes from the November 2013 exam paper, right? So, ball of mass, very important, 0.15 kgs, is thrown vertically downwards from the top of the building to a concrete floor below. The ball bounces off the floor. The velocity versus time graph below shows the motion of the ball. Ignore the effects of air friction. Take downward motion as positive. So very important, they've specified take down as positive. Now here, the reason they say the ball bounces, so when they give us mass, they generally will test impulse. Right, so if you look at the graph, there the ball starts. When it's thrown down, its initial velocity is 10. Right, after a certain time, when it makes contact with the floor, it hits the floor at 20 meters per second. Right, so that's what that graph is showing. Then there it starts again. When it bounces off the floor, it bounces off the floor from negative 15 meters per second. Right, it goes to its highest point, which is there at point T when velocity is 0. So remember the highest point, final velocity is 0 there before it travels down and it speeds up due to gravity. Right, so 3.1 from the graph, write down the magnitude, the velocity at which the ball bounces off the floor. Is the collision of the ball with the floor elastic or inelastic? Refer to the data on the graph to explain your answer. 3.3, calculate the height from which the ball is thrown. 3.3.2, magnitude of the impulse imparted by the flow on the ball. So that is where the mass comes in, and velocity. And then 3.3.3, magnitude of displacement of the ball from the moment it's thrown until time t. Right, now remember, very important, there's also, as I said, a graph question, but that graphing question I've written separately after we've answered this, right? I don't want to squeeze everything on one page. Right, so from the graph, write down the magnitude at which the ball bounces. So remember, starts at 10, makes contact with the floor at 20, and when it leaves the floor, it's leaving at negative 15 meters per second. So there it's leaving the floor at 15 meters per second. The collision of the ball with the floor elastic or inelastic? Refer to the data on the graph to explain. So there, when it makes contact with the floor, it makes at 20 meters per second, but leaves at negative 15. So that velocity is not the same, therefore it can't be an elastic collision. There's a change in kinetic energy, right? And that normally happens when it made contact with the floor. It either made a sound, which to make sound requires energy, so energy is lost there. At the same time, being in contact with the floor, the friction and it making contact with the floor, the friction there also requires energy. Heat is given off, so therefore it can't leave with the same speed it started. So answer is inelastic, and this in short we can just say the speed at which the ball leaves the floor, there negative 15, is less than at which it strikes the floor. Right, so it strikes at 20 and it leaves at negative 15. Right, next question. 3.3, calculate the height from which the ball is thrown for 4 marks. So again, there's my 4 equations for motion. We know this object had an initial velocity of 10 meters per second. When it made contact with the floor, it was at 20 meters per second. While being thrown through the air, gravity always acts, so gravity there, 9.8 meters per second. And to know the change in x or change in y, how far did it travel? Right? So I have initial velocity, I have final velocity, right? But I want the change in x, so I'm going to work with equation 1. So Vf squared equal Vi squared plus 2a, change in x. Final velocity 20 squared, initial velocity 10 squared, plus 2ax, my acceleration, gravitational acceleration 9.8, and change in x. Alright, 20 squared is 400, minus 10 squared, which is 100, gives me 300. 2 times 9.8 gives me 19.6, so 300 divided by 19.6, change in x, and that gives me a distance of 15,31 meters. Right, so from the time I've thrown the ball till it makes contact with the floor, it travels 15,31 meters. Right, 3.3.2, the magnitude of the impulse imparted by the flow on the ball. So for impulse, remember it's change in momentum, equals my mass times final velocity minus initial velocity. So the mass was given to us as 0,15 kgs. Final velocity, right, negative 15. Initial velocity, 20. Right. So it makes contact with the floor with 20. That leaves the floor at negative 15. So initial 20, final negative 15. So negative 15 minus the 20 gives me negative 35 times 0,15 gives me negative 5,25 newtons per second. They only wanted a magnitude, so their magnitude equal 5,25 newton seconds. One for correct formula, one for correct substitution, and one for correct answer, right? So that's based on the graph. Next question. Calculate the magnitude of the displacement of the ball from the moment it's thrown until time t. So we want to know how far it moved to get to t. So again, we have initial velocity there when it leaves, negative 15 meters per second. At t, there you can see the velocity is 0, final velocity. We know gravity is what slowed it down, so it's 9,8 meters per second. How far did it travel? Alright, so my final velocity is 0. Initial velocity, negative 15 squared, plus 2 times 9,8, change in x. So 15 times 15 gives me 225. Right, so it becomes positive here. If I take it to the other side, negative 225 divided by 19,6 equal change in x. So my change in x equal negative 11,48 meters. But remember, the object started from top to bottom, it traveled 15,3. So it's traveling 15,3 there, and it's traveling 11,48 back. So displacement is the shortest distance between the 2 points, so 15,3 minus 11,48, and it displaced itself 3,82 meters from where it started to get to t. Alright. Now next question is the graph question. Sketch a position versus time graph, or displacement versus time, or distance versus time graph for the motion of the ball from the moment it's thrown until it reaches its maximum height after the bounce. Use the floor as 0 position, so meaning where I started. When I make contact with the floor, I reach 0, and indicate the following on the graph. Alright, so there we're starting from 15,3 meters. Right, and from there to travel 0, we're increasing, so we're going from minus 15,3 to 0. Then remember, after the bounce, we traveled 11,48 meters back. So from there to there is a 3,4 somewhat meters. So that was at time t. It was almost back, but didn't go back because we lost part of the energy in the form of sound and friction. Right, so I hope you follow. God bless. Bye.